theta as theta approaches to 0 is equal to 1. This is the common question being raised by calculus students, especially in college, why it is equal to 1. And commonly, as based on my experience when I was still a student, commonly the teacher will only tell us that it is a theorem, and the teacher will not give us the reason why it is 1. So in this video, we will reveal why it is 1. So to answer that, to prove that this is really equal to 1, we will be using this unit circle. And we all know that the unit circle is a circle wherein the center is at the origin and the radius is 1. Okay, so what we will be doing is we are going to determine this point. By the way, the radius is 1, so this measurement is 1. So automatically this is a terminal point or of that quadrantal angle, so it means it is just 1, 0. This is 1 and y is 0. So this is a terminal point in your unit circle, the intersection between the terminal ray and the unit circle, the terminal point. And we all know that the terminal point is just cosine of your angle theta, sine of your angle theta. Okay, how about this one? So what we will be doing is we will be using tangent theta. Why we use tangent? Tangent is just opposite all over the adjacent side. So to determine, we don't have problem about the abscissa. Our problem is the ordinate. So to determine the ordinate of that point, we will be using tangent. So tangent of this theta is opposite, so let us say it is y. This is y. The opposite is y, and the adjacent is 1. And if we simplify it, it is just equal to y. So it means y is just equal to tangent of theta. So this is just tangent of theta. If that is tangent of theta, then we can easily determine, let's erase this, we can easily determine that the coordinate of that point, it is the point, the x value is 1 and the y value is tangent theta. Okay, to continue, we will be finding the area of this bigger right triangle, and we all know that the area of a triangle is 1/2 the base times the height. So obviously the base here is 1 and the height is tangent, as we all know a while ago. So it will be 1/2, the base is 1 and the height is tangent. So 1/2 times tangent, or it is just tangent theta over 2. Clear? The next portion is the area of the sector. So it is just 1. This is the theta, so it means it is just pi times this length and times the theta. So it is just 1/2 this length, this radius, and the theta. So it is just theta over 2. While the area of the smaller triangle, so 1/2 base is also 1. This is also 1, but the height this time, remember, this is the point sine theta, cosine theta, sine theta. So this must be the point. This must be the area of this must be, base is 1 and the height is sine theta. Sine theta 1/2, or it is just sine theta over 2. So it is greater than or equal, greater than or equal. After that, after we get this inequality, what we will be doing is we will try to rewrite this denominator into something like sine theta over theta, and it is a little bit hard, but it will be easy if you will be multiplying both in all quantities in your equation by 2 over sine theta. Why 2 over sine theta? 2 over sine theta because if you multiply it here, 2 will be cancelled out. You can multiply it in the denominator, so you have theta over sine theta, and you will take the reciprocal later. So we will be multiplying this in each quantity. So if you multiply it there in the first quantity, tangent theta over 2, the 2 will be cancelled out. And remember, tangent is sine over cosine, so the sine will be cancelled out. So you will get here 1 over cosine of theta, greater than or equal to, you multiply 2 over sine theta, the same quantity that you multiply in the first. So if that will happen, 2 will be cancelled out, so you will now have theta over sine theta, and the same will be multiplied to the other side. So obviously the sine will be cancelled out as well as 2, so it is just 1. So you will now have this. After that, we are going to take the reciprocal. Remember, if you take the reciprocal, the inequality will be changed to its opposite direction in the property of inequality. So by that, it will be cosine theta, it will be sine theta, the form that we are looking for. The reciprocal of 1 is also 1. Since we get the reciprocal, the inequality will be changed to its opposite direction, so it will be less than or equal to less than or equal to. Okay, now you may wonder, if we will change the value of theta by its negative, can this inequality be still working? It might not, it might be yes. Okay, remember, this theta can be positive. If this is positive, it will work. But if we will change it to the negative value of theta, then can it still work? Yes, the answer is yes. Remember, cosine theta is an even function. If you mention of even function, if you will change the value of theta by its negative, it is the same with the original. Means cosine of the negative theta is the same to the cosine of theta. So it means no problem here if we will change this by negative. And remember, sine theta is an odd function, just like tangent, but we will not be using the tangent. It means if you will change this by negative, so you will have sine of negative theta over negative theta. And remember, sine is an odd function, so if you change the input by its negative, it is just negative sine of your theta. The sine of negative theta is the negative sine theta, because sine theta is an odd function. So you will have negative theta, you copy the denominator, and if you simplify, it will be reduced into sine theta over theta. So in this case, they are just the same. They are just equal. So we don't have problem here. So it means it will also work. Now, so after that, since we are looking for the limit of sine theta over theta as theta approaches to 0, so it means we will get the limit of cosine theta as theta approaches to 0 and the limit of 1 as theta approaches to 0, because in the squeeze theorem, it states that if the limit of this is any value and the limit of this is the same with that value here, then the limit of this is the same with their limit. So let us try. Maybe their limits of these two are the same. If they are the same, it will automatically say or tell us that the limit of this is the same with their limit. That is the squeeze theorem. So let us get the limit of cosine of theta as theta approaches to 0. And we all know that we can substitute that 0 into cosine, so you have cosine of 0. And we know that the cosine of 0 in our trigonometry, if this is 0, it is a quadrantal angle, and this is the point 0, 1, right? Oh no, it's 1, 0 rather. 1, 0. So since we are looking for cosine, so it is for the abscissa or the x coordinate. So this x coordinate of this point, that quadrantal angle, this terminal point of that quadrantal angle is 1. So the limit of cosine theta as theta approaches to 0 is 1. While if you get the limit of 1 as theta approaches to 0, since this is a constant, it is 1. And they are the same. So it means it will tell us automatically that the limit of sine theta using the squeeze theorem as theta approaches to 0 is also 1. And that's the end of proof.